Kia ora Year 12. This video is going to revise how we can write a quadratic equation when we're given the roots. It also leads us into level 2 graphing. I'm going to do two things in here. I'm going to go over how the scale factor works on a quadratic equation and also look at the discriminant stuff that we've learnt in the last few weeks. I just want to say now that I've got a band practicing in my house at the moment, so if there's background noise in this video, I'm really sorry, but I just want to try and get it done this afternoon. So I want to start by looking at some different graphs and thinking about what we know about them. So this one here, this first one, is my basic parabola. This is y equals x squared. You can see that by looking here at the scale. We've got a point here which is 5, and you can see that the point 2, 4 is on that curve. Okay, so that's the basic parabola. What else can I say about that? Well, it's touching at one point. It doesn't cut through the axis, so it has a discriminant that is 0. Right? And we can see that because y equals x squared plus 0x plus 0. So we've got a is 1, b is 0, c is 0. So b squared minus 4ac is equal to 0 squared minus 4 times 1 times 0. Right, so that equals 0. But if I look at the graph, I can see that discriminant straight away is 0 because it's just touching at this point here. Now I want to look at some different transformations of that basic parabola. So if you just look at this graph here, we've got three equations. The black one is y equals x squared, right? Now, the red one and the blue one have been squeezed in tighter. The red one has equation y equals 2x squared, and the blue curve has got equation y equals 5x squared. All of those graphs have got a discriminant that equals 0. And that's because all of them are just touching the x-axis. They don't cut through it. Next, we go on to looking at one where we've got an upside down parabola. So the green one is the reflection of the black curve in the x-axis. And that's going to have the equation y equals negative x squared. And it also has a discriminant of 0 because you can see it just touches the curve here. And if you put all of those onto one graph, you can see how the scale factor is affecting the curve, right? So remember this one here is my basic one, y equals x squared. So far this year, mostly what we've worked with is just the algebra and not the graph, but we're starting to link those things up now. Okay, so as this number gets bigger, my parabola gets squeezed in more. Right, so here we go with some discriminant work. I've got two graphs on here. What can I say about the discriminant here? Well, all we want to look at really is it positive, is it 0, or is it negative? So for this graph here, we can see that the curve cuts the x-axis twice. So that means that the discriminant is positive. And for this one here, we can see that the curve cuts twice, so the discriminant is positive for that one. What about these next two? Well, in this case here, the discriminant is equal to 0 because the curve just touches the axis. And for this last one, it doesn't touch the axis and it doesn't cut through it, right? So there's no root up here. So this is one where the discriminant is negative. Okay, I'm going to try now to move on to some questions where you're told the roots and we need to make some statements about the discriminant and then find the equation of the curve. And the questions are all really, really similar on purpose. So the roots of a quadratic equation are 3 and 4. That means that we know that y is equal to something times x minus 3 times x minus 4. But we don't know the scale factor yet. So what do I know about the discriminant of this quadratic? Well, I know that it's got two roots, so the discriminant must be positive. Now, this last part of the question is asking me what the equation is. I'm told that the point 0, 12 is on the curve. So what is the equation? Well, so far what I know about my equation is that it's that y is equal to something times x minus 3 times x minus 4. And we can call that scale factor k. To figure out what that scale factor is, I can substitute in my point. And in this first one that I've done, this works out to be really, really easy. So y is 12, and we've got k, which we don't know yet, and my x value is 0. So this is my basic parabola case. I've got y is equal 12 is equal to k times negative 3 times negative 4. 12 is equal to 12k, so k is equal to 1. That means that my equation is simply x minus 3, x minus 4. The other way that I could have got that is by expanding out this and seeing that I get a plus 12 on the end. Right, so just working with our basic equation is going to get me the point that I want. And if we look at a graph for that now, let's see how it looks. Right, so this is, oh, where's my first question gone? Nope, that's not the first question. We'll leave that one for now. Okay, the next one, the only roots of a quadratic equation. The only root is 3. So if there's only one root, we know that the discriminant must be 0. Okay, one root means discriminant 0. That means my equation must be y equals something times x minus 3 squared. And we can see that the point 0.09 is on the curve. So let's write in my scale factor and substitute in that point. We've got 9 is equal to k times 0 minus 3 squared. So 9 is equal to k times negative 3 times negative 3. 9 is equal to 9k. So again, I've given you an easy one. K is equal to 1. That means that the equation of the curve is y is equal to x minus 3 squared. And we know the discriminant 0 because there is only one root. Let's see if we've got a graph for that. Yep, here we are. This is the graph here. So the only root is at 3 here, the discriminant 0, and this is my point. 0.9 is on the curve. Right, I want you to pause the video now and try and do the next 3 questions using this method. So work out something about the discriminant, then write an equation and leave your scale factor in there as k. Use the point to solve for the value of k. And then unpause the video and I'll go through these other questions quickly and show you the graphs. Okay, so for this one we've got 2 roots, so the discriminant must be positive. The equation has got roots 3 and negative 3, so it's going to be a scale factor times x minus 3, x plus 3. We know that 0.9 is on the curve. We substitute that in. We get negative 9 is equal to k times 0 minus 3, 0 plus 3. Negative 9 is equal to k times negative 3 times 3. Negative 9 is equal to negative 9k. K must simply equal 1 again. So my equation is y equals x minus 3 times x plus 3. The next one also has 2 roots. They are 3 and negative 4. So the equation will be x minus 3 times x plus 4, but we don't know the scale factor yet, so we squeeze that in. We know, because there are 2 roots, that the discriminant must be positive, right? Because this is one where it's cutting at negative 4 and positive 3. So it's going to look like this. And we're told that the point 0, negative 12 is on the curve. So negative 12 is equal to k times 0 minus 3 times 0 plus 4. Negative 12 is equal to negative 12k, giving us k is equal to 1. So the equation of the curve is simply y equals x minus 3 times x plus 4. Right, now finally in these last two, hopefully you found that I'm giving you a scale factor to work out. Right, so in the next question, we've got two roots again. They are 3 and 4. So that means that the discriminant of the quadratic is positive. So we know that this graph is going to look something like this. But we don't know if it looks like that or if it looks like that. This is a terribly badly drawn graph, but hopefully it gives you the idea, right? So because we know the roots and we know that it's a parabola, we kind of know the shape, but we don't know how stretchy or squeezy it is, right? So we need to have this point here to tell me the scale factor. So this equation will be y is equal to k times x minus 3, x minus 4. But this time when we do our substitution, we're going to get 24 is equal to k times 0 minus 3 times 0 minus 4. So 24 is equal to k times negative 3 times negative 4, and that equals 12k. 24 is 12k, so k is equal to 2. So this is the first one that you've seen for a while where we've got a scale factor that's not just 1. Let's look at what the graph looks like for this curve. So you can see here, this is it here, we've got the roots of 3 and 4. If it had a scale factor of 1, then the intercept would be 12. But here I've drawn both together, and our curve has a y-intercept of 24. So this is what it looks like. It's got a scale factor of 2. So it's 2 times x minus 3, x minus 4. Right, just back to that very last one, and that'll be all for now. Okay, the roots of a quadratic are 3 and negative 3. What do we know about the discriminant? There are two roots, so the discriminant is strictly positive. And the point 0.09 is on the curve. So this time we've got y is equal to k times x minus 3, x plus 3. And the point 0.09 is on the curve, so 9 is equal to k times 0 minus 3, 0 plus 3. 9 is equal to k times negative 3 times 3. 9 is equal to negative 9k. So in this case, k is equal to negative 1. What does my parabola look like? Well, my parabola is going to have this equation. And this means that we've tipped the basic one upside down like this. Here, right? So this one here is y equals x minus 3 times x plus 3. But this one, that's right. But this one here, the purple one, has got roots of 3 and negative 3, but it goes through positive 9. So its equation is y equals x minus 3, negative x minus 3 times x plus 3. There you go. Thanks for watching. This probably will feel a bit weird now that we're starting to do some graphing with the algebra, but hopefully it will firm up your understanding of the roots of the equation, the discriminant, and how to find the equation.